In Part 1, we covered what data integrity means, Alcoa Plus, the data lifecycle, and the two families of controls. Now, we go deeper into the second family, the technical controls. These are the safeguards built into your system itself, the ones that can't be skipped on a busy day. There are 5 of them, and together they stand guard over the 6 stages of the data lifecycle. 2 of them, access control and the audit trail, never sleep. They protect every stage. The other 3 stand guard at specific gates. Let's take them one at a time. Control 1, access control. Attributability, the A in Alcoa Plus, starts at the login screen. Every action should tie to a named, unique individual. That's what makes the who in every audit trail entry mean something, and it's the foundation the other 4 controls stand on. Which brings us to the most common finding inspectors make: shared logins. One password everyone knows, a generic lab user or admin account. The moment a login is shared, attributability is gone, for every record made under it. An audit trail full of lab user 01 isn't a record, it's a confession. Fix it first. It quietly invalidates every other control. Good access control has 3 layers. Authentication, unique user IDs, never reused. Password rules, automatic lockout, a session that locks when you walk away. Authorization, least privilege. You can only do what you're qualified and authorized to do. An analyst acquires and processes, but can't approve methods or delete data. A reviewer signs at review level, but can't review their own work. QA gives final release. This isn't distrust. It's making sure no single person can create, approve, and erase the same record. And a life cycle. Access requested and approved, provision to a role, reviewed on a schedule, and, the day someone leaves, deactivated, not deleted, so their history stays attributable forever. Control 2. The audit trail, the silent witness. A compliant audit trail answers 5 questions, automatically. For every action: who did it, what changed, the old value and the new. When, from a trusted, synchronized clock. Where, which record and instrument, and why, a reason the user enters or selects. The key word is automatically. The trail is generated by the system, not the user. It's contemporaneous, it can't be paused, and it can't be edited. It rests on 2 foundations. Trusted time. Every clock synchronized to a controlled source, and no one, not even an admin, able to change it quietly. Results dated before their injections are an instant red flag. And authenticated identity. Every entry inherits the unique logged-in user from access control, which is why the 2 work together. And it isn't one trail. A modern system keeps several: a system log for logins and configuration, a data trail for result changes and reprocessing, method version history, and instrument logs. One inspector question can touch all 4. Knowing where to look is a trained skill, but an audit trail nobody reads protects no one. Review has to be a strategy, not a ritual. Routine. With every result set, the entries that affect the reportable result, manual integrations, reprocessing, reason codes, periodic, sampling the system-level trail, user administration, policy changes, disabled accounts, and for cause. Triggered by an out-of-specification result or a suspicion, a full reconstruction across every trail. Write that strategy into an SOP. We review audit trails. With no scope or frequency, convinces no one. So what are you looking for? 7 patterns every reviewer should know. 1. The same injection reprocessed until it passes. 2. Manual integration applied only to failing results. 3. Aborted or test injections just before the official run. 4. Results deleted, renamed, or moved into unusual projects. 5. Activity under a login while that person was provably absent. 6. Time gaps, clock changes, or entries out of order. 7. A review signature seconds after the result was created, a review that couldn't have happened. A red flag is a question, not a verdict. But an unasked question is a finding, and the trail itself is protected. It can't be switched off, entries can't be edited or deleted, and it's retained alongside the records it describes. Control 3. Electronic signatures, where accountability attaches. An electronic signature proves 4 things: that a named individual approved this specific record, the meaning of that approval, reviewed, approved, or released, the date and time, from trusted time, and legal equivalence to a handwritten signature. It sits at review and report the moment a result becomes a decision. A compliant signature has 3 parts, 2 components: a user ID and a private password known only to the signer, or a biometric. A manifestation. The signed record shows the full printed name, the date and time, and the meaning. And an unbreakable link. The signature is bound to that one record. It can't be copied, moved, or reused. Because identity is unique and the link is permanent, the signer can't later deny it. That's non-repudiation. In daily practice, re-authenticate at the moment of signing, not just at login. Use explicit meanings. Never sign for a colleague. That's falsification. And never sign what you didn't actually review. The audit trail timestamps your signature, and a review that took 3 seconds tells its own story. Control 4. Secure storage, backup, and archival. This is enduring and available, made real. Records have to outlive the people and the software that made them. That means central, controlled storage, a managed database, not files on someone's C drive. A record that lives in one person's folder lives one accidental delete away from a data integrity event. Loose files can be copied, renamed, or moved, and USB drives and email attachments break the chain of custody. Then, backup and archive, and they're not the same thing. Backup protects against loss, regular, automated, and this is the part inspectors probe, periodically restore tested. A backup you've never restored is a hope, not a control. Archive preserves records for the full retention period. Written, once, read-only, retrieval logged, and still readable after the software that created them has changed. And integrity has to survive the bad day. Network or server loss? Instruments buffer locally and reconcile, with no silent gaps. Power failure. The system records the event instead of losing the run. Disaster recovery. A documented, tested plan where the copy is, who restores it, how long it takes. And at the end of retention, destruction is deliberate, authorized, documented, and irreversible, never ad hoc. To an inspector, a lost record and a deleted record look identical. Control 5. Built-in, validated calculations, accurate by design. The moment a number leaves your system to be calculated somewhere else, you've created risk. The unvalidated spreadsheet is the single most common shadow system inspectors hunt for. Numbers transcribed by hand, formulas anyone can change with no version history, a cell overwritten by accident and invisible in the result. The answer is to keep the math inside the validated system. System suitability checked automatically against acceptance limits. Assay, impurities, %RSD signal to noise, computed natively. The reportable result derived and flagged pass or fail, with every parameter change captured in the audit trail. Validate the calculation once, and it's applied identically to every result, with no transcription. If you truly must use a spreadsheet, treat it as a computerized system. Validate it, lock the formulas, control the versions, and put change control around it. Better still, eliminate it. Every number that leaves the system in a copy-paste is a number you can no longer defend, so there are your 5 technical controls. Access control and the audit trail, guarding every stage. Electronic signatures at review and release. Secure storage across retention. Validated calculations at processing. Turn policy into physics, and the system simply won't allow the wrong thing to happen. But there's one thing that makes all 5 easier, or harder, where your data actually lives. In Part 3, we'll look at architecture, how a central client-server system makes every one of these controls the default instead of a daily chore, and why that's a data integrity decision, not just an IT one. And we're running a free, practical webinar on the data integrity gaps most common in chromatography. Follow CoreLab Technologies to catch the date.